Hello everyone! Welcome to Jhane's channel. Before anything else, I would like to greet you all Merry Christmas and Happy New Year. In today's math tutorial, we will be dealing with the angle of depression and the use of trigonometric identities and the use of law of sine formula. Just a quick review of the angle of elevation, depression. For example, we have the building. And there is a man standing here. And we have also a tree here. For example, the man is looking on top of the tree. That means he's seeing from the top of the tree here. That means the angle of depression is this one, from the horizontal going to this line where he's seeing at the top of the tree or at the base of the tree, wherever in the portion of the tree. That means the angle, for example, on the base of the tree, the angle of depression is this one, from the horizontal going to this side. Now, when it comes to trigonometric identities, for example, we have this. We designate at y, x, and r. And we designate the angle as theta. So, sine of theta is equal to, of course, the opposite over the r. Cosine theta is equal to the adjacent over the r. And tangent theta is equal to the opposite over the adjacent. This is the one very important identities. Now, when it comes to the law of sine, well, if we have this triangle, for example, we have this angle A, B, C. So, this is angle A, angle B, and this is angle C. And this is the side B, this is side A, and this is side C. So, what is the law of sine formula? Law of sine formula states that it is one side, for example, over the angle, what is the A? The angle is theta, and then, for example, C side over what is the opposite angle of C side, which is sine beta, and B side over the opposite angle, which is sine alpha. This, we can use this one if, for example, two angles are given and one side is given, so we can solve the other side. For example, two angles are given and this one is given, so we can solve C side. That means this is this formula, we can use it. This is, we call it the law of sine formula. The question: a 40-meter high tower stands vertically on a hillside, sloping ground, which makes an angle of 18 degrees with the horizontal. A tree also stands vertically up the hill from the tower. An observer on top of the tower finds the angle of depression of the top of the tree to be 28 degrees and the bottom of the tree to be 40 degrees. Determine the height of the tree. Now, this question, there are two ways to solve this. You can using the trigonometric identity, or you can solve this one using the law of sine. Now, first, I will show you using the tangent function. Here, of course, to minimize the time, I have to write already the solution. So, here it is, the rough sketch of the tower and the tree. Now, they are resting on the sloping ground with an elevation of 18 degrees from the horizontal. It is written that it is 18 degrees from the horizontal, so it is on a sloping ground. So, the tower is resting on a sloping ground with 18 degrees from the horizontal. So, here it is 18 degrees. We designate the height of the tower as HT. And then, a tree stands vertically also up the hill. So, here it's the tree. Then, there is a man standing on top of the tower, and he's observing from the top of the tower to the top of the tree the angle of depression is equal to 28 degrees. This is from the top to the top of the tree. Now, another thing is the angle of depression from the top to the base of the tree is equal to 40 degrees. So here it is 28 on the top and 40 degrees on the base of the tree. Now, we designate this from this one to this one as D. So, and this one, we designate this one from this top of the tower to the horizontal line up as C, and the height of the tower as small h t. And we designate the points as this is A, B, C, and D. Now, here it is. The height is equal to the B times the D. See? It's equal to the B plus the D. So, here, we can find D because, you see, we have this one. And we have a right triangle here. So, here, the angle is given. So, tangent of 40 degrees, which is the opposite over the adjacent. The adjacent, we designate this from this one to this one as A. The side is A. Okay? So, tangent of 40 degrees is equal to the opposite over the adjacent, which is equal to D over A. And the other one is tangent of, okay, this is the D. Now, the B also, we can find the B as using this from here. We have right triangle also. And we have the given 18 degrees. So, tangent of 18 degrees is equal to the opposite over the adjacent, which is equal to B over the A. Therefore, here, D therefore is equal to A tangent 40 and B is equal to A tangent 18 degrees. Substituting all this one here, plus the height of the tower, which is 40 meter, therefore, A, which is the distance from A to C, is equal to 34.36 meters. So, meron na tayong A dito. Distance from this one to this one, which is equal to 34.36 meter. Now, what we're looking here is the height of the tree. The height of the tree is this one, which is equal to D minus C. So, C also here, we can find C using the tangent function again. Tangent 28 degrees is equal to the opposite, which is C over the A. Of course, A is already given. We solved already as 34.36. So, therefore, C is equal to A tangent 28 degrees. Now, we can substitute these values already to this one because we have the value of D, which we solved earlier as A tangent 40 degrees, and C, which is equal to A tangent 28 degrees. Now, substituting all these values to this, it's the height of the tree, therefore, is equal to D, which is A tangent 40 degrees, minus the C, which is equal to A tangent 28 degrees. Grouping this together, taking the A out, because it is common. Therefore, A times, parenthesis, tangent 40 degrees minus tangent 28 degrees, close parenthesis. Therefore, A, which is equal to 34.36, times tangent 40 degrees minus tangent 28 degrees. Of course, you have to use your scientific calculator to solve all this one. Height of the tree, therefore, is equal to 10.56 meter. This is the first way to solve this problem. Another way of solving this problem is by using the law of sine formula. So here, sa sketch natin dito, makikita natin yan. See? Pwede tayo maka-form ng triangle. Yan, linabas ko yung triangle niya. Dito, kasi dito may 40 degrees na siya. Diba? Tapos, right triangle kasi yan eh. Right triangle yan dito. Right triangle, that means, kung right triangle yan, it is 90 degrees. So, kung meron na ditong 40 degrees, from here to here, that means, ang balance niya is 50 degrees. 90 minus 40 is 50 degrees. Dito naman, dahil 40 degrees yan. Of course, ito rin 40 degrees. Why? Because alternate interior angles are equal. Alternate yan eh. Kasi ano yan, two parallel lines, tapos may transversal line. So, ang angle nila dito, at saka ang angle dito, at saka angle dito, is the same. So, 40 dito, 40 din yan. Ito naman dito, dahil dito, pwede rin tayo makaform dito ng there are two parallel lines, tapos may transversal line. So, dahil given itong 18 degrees, therefore, itong angle rin ito, alternate interior angles, which is 18 here, so must be 18 here. So, ang total niyan sa loob is 58 degrees. Now, meron ka ng 58, merong 50 degrees. Now, according to the mathematics, the sum of the interior angles of a triangle is 180 degrees. So, kung meron ka ng 58 degrees dito, meron kang 50 degrees, minus, so 180 minus this two angles is equal to 72 degrees. So, here it is, linabas natin yung triangle. Here is this 50 degrees, this is 58 degrees, and this is 72 degrees. Now, from this one, we can use the law of sine formula, which is equal to, dahil ang BA is equal to the height of the tower, which is given to be 40 meter. So, height of the tower over the opposite angle, which is equal to 58 degrees. So, sine 58 degrees is equal to R over the sine 72 degrees. Yan ang opposite ng R, which is 72 degrees. Therefore, we can, substituting the value of HT, which is equal to 40 meter, therefore, R is equal to, by close multiplication, 44.85 meter. So, meron na tayong R. Na-solve na natin ang R. Ang hinahanap natin dito is the height of the tree. Now, dahil dito, pwede na naman tayo makaform dito ng triangle. Ito dito, oh. Here it is. It is an scalene triangle. Now, dito, dahil ito, 40 degrees na yan, ito, right triangle na naman yan. So, 90 degrees minus 40 is equal to 50. So, 50 yan. 50 degrees yan nandito. From here to here is 50 degrees. Now, dito naman, dahil meron tayong what you call this one, 28 at meron 40, so ano to? Anong angle to? 40 minus 28 is equal to 12 degrees. 40 minus 28 is equal to 12 degrees. So, nandyan na naman yung 12 degrees. Now, how to solve this angle? This one we find, this one also we solve, and this one we have to find this one. As I've said earlier, that the sum of interior angles of a triangle is equal to 180 degrees. So, 180 degrees minus 12 minus 50 is equal to 118 degrees. Now, therefore, here we can solve now the height of the tower, again using the law of sine formula, which is equal to the height of the tree over the opposite angle, which is equal to 12. So, sine 12 degrees is equal to R over the opposite, which is equal to sine 118 degrees. Therefore, substituting the value of R, which we solved earlier, which is 44.85, height of the tree, therefore, over sine 12 degrees is equal to 44.85, the value of R over sine 118 degrees. Therefore, the height of the tower, the height of the tree, is equal to, by cross multiplication, is equal to 10.56. That is the height of the tree we are looking for.